Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss some very important quiz questions related to support vector machine. All these concepts, whatever I have discussed, all the mathematical intuition, all the MATLAB implementation, all the visualization we can use or gather together to give the answer, right? And if we solve this kind of question, then this surely it is going to help us in machine learning or data science related interview process. If interviewer asks you some question related to SVM, then this set of questions is surely going to help you to give answer that time. Okay, so here comes the first question, and the question is: suppose you are using a linear SVM classifier with two-class classification problem. Now you have been given the following data in which some points are circled red, okay, and those are basically representing my support vector. And the question is, if we remove the following any one red data point from the data from my whole data set, does decision boundary will going to change? Option A yes, option B no. Pause my video, try to think about the correct answer, and then check whether your predicted answer is matching with my answer or not. Here I am giving the correct answer. Okay, so the answer is option A. If you remove any one red data point, which is basically support vector of my classifier, then surely decision boundary or the separating hyperplane going to change, right? So in my previous video where I was discussing why SVM works exceptionally well or brilliantly in high dimensional data, that time I have told you that support vectors are very important for SVM classifier. Those basically helps our hyperplane or support our hyperplane to do its work, right? Now if you remove any of support vector itself, then obviously our hyperplane going to change. But apart from support vector, you remove any training data, it will not affect our model. Okay, so support vectors are very important. You should keep that. That's why SVM is memory efficient also, because when you are creating the model need not keep all the training data in memory. Okay, only those training data point or those training vectors which are basically support vector, which basically helps our hyperplane, those only our model has to remember, right? Apart from all those data which are basically not support vector, our machine can ignore and no need to store that even. That's why SVM is very much memory efficient, right? That's what I have discussed. So this is obvious answer is yes. If you remove any of the red data point which is basically denoting my support vector of my classifier, obviously decision boundary going to change, and this you can easily answer from the mathematical intuition, derivation, visualization, whatever I have discussed, right? Coming to the second very important concept. Okay, here I will be discussing this concept, then I will go to further question. Okay, because you should understand this concept very clearly. Hard margin and soft margin in SVM. We have discussed margin, right? Detailed derivation I have shown you related to margin. Now there are two types of margin. One is hard margin, another one is soft margin. What is hard margin? Hard margin is the one which clearly separate positive and negative data points, or data points belonging to positive class or negative class. Okay, that is perfect classifier. Okay, with zero training error we can say. And what is soft margin? Soft margin is noisy version of my linear SVM, which includes some misclassification points. Okay, it allows some misclassification, but hard margin never allow any misclassification. So how the picture will look like? The picture will look like this, right? So as you know, main hyperplane equation omega vector dot x vector plus b equal to 0, or we can say omega transpose x plus b equal to 0, or we can say dot product of omega and x plus b equal to 0, whatever you say, right? Same, denoting the same. Now this is soft margin support vector machine, and here this is hard margin support vector machine. You can clearly understand that. See, here two different class denoted by two different colors. One is dark blue, one is sky blue, right? And here you can see, if this is my actual hyperplane which basically separates these two class, here one data is coming which is belonging to this dark blue class, but this should not come, right? Because if this is the hyperplane or decision boundary, what should happen? Ideally, all this data belonging to dark blue class should present in the right hand side of this particular hyperplane, and all this sky blue color class data should present in this side, right? But see, it is allowing some misclassification, like here you can see one dark blue color data is coming, right? So this is soft margin SVM, and this is hard margin SVM. It will decrease the margin as much as possible, but it will not allow a single misclassification. You can see that here, although we are getting very small margin, but it is not allowing any misclassification. No misclassification is present, right? All the data belonging to sky blue color is present here, all the data belonging to dark blue color present here. So this is hard margin, right? And let us try to understand little bit more about hard margin and how this is related to C parameter. Okay, so this is soft margin SVM, this is hard margin SVM, as I have discussed. So one thing it is clear, hard margin will result into overfitting of a model that allows zero error, right? So in training data, if you are getting zero error, that means what? That means overfitting, right? So this is what I wanted to discuss with respect to overfitting point. Now coming to C parameter. So if you just recall the concept of C parameter, what I have discussed, that in support vector machine we have two target basically. One is setting the large margin, another one is lowering the misclassification rate. Now if you try to make large margin, then what will happen? You will be getting more misclassification rate. Okay, you will be getting some misclassification, and if you want to lower the misclassification rate, then obviously you have to reduce the width of the margin, right? That is, these two targets are basically contradictory. If we increase margin, we will end up getting high misclassification rate. On the other hand, if we decrease margin, we will end up getting lower misclassification rate, right? So these two things are contradictory, and that's why C parameter came. Because we might think that okay, fine, we always require lower misclassification rate, but no, it will lead to overfitting, right? If you decrease the margin very much with almost zero misclassification rate, such model if you create, that might work very well in training data, but in the validation data or in the test set data, it will not at all work properly. So that's what we need to focus more on, setting the large margin or width of the margin as high as possible. Okay, that's why the parameter C came. If we specify large value of C parameter, we will be getting small margin, right? That is very small misclassification, or the misclassification will be lowered as much as possible. But if we define small value of C parameter, then we will be having large margin and misclassification rate will be there. Okay, it will be significant. So these two are basically contradictory. So using C parameter, this is basically regularization factor present in SVM, using which we can control the overfitting. Now you can relate C parameter with hard margin and soft margin, right? Suppose you want hard margin, then what you should do with C parameter? Correct. Hard margin basically does not allow misclassification, and large value of C makes small margin, and eventually it's lead to lowering the misclassification rate. So hard margin means large C parameter, and soft margin means small C parameter. In soft margin, you try to avoid the overfitting, but if you want to make your such model which will work brilliantly for training data, and you are not that much bothered about validation data or test data, then you go with hard margin and keep your C parameter as high as possible, right? Sometimes you might put infinite also. So C is actually determines how much penalty you want to give with misclassification. If C is large, that means more penalty you are giving with misclassification. That means our model will try to reduce the misclassification rate, right? So this is how it is related to hard margin, because hard margin target is also same. That is, you can reduce misclassification rate, okay, and you have to pay for margin. You have to reduce the margin also. So hard margin is related to large C parameter, right? Then here is the quiz question related to this. When the C parameter is set to infinite, which of the following holds true? The optimal hyperplane, if exists, will be the one that completely separates the data. Option B, the soft margin classifier will separate the data. Option C, none of these. So the correct answer is correct, option A, because C infinite means very large value of C. Okay, overfitted model. So that is hard margin. So hard margin, that is if such hyperplane exists for which we will be getting such margin in which no misclassification is present, that is optimal hyperplane if exists, that will be resulting in our model. Okay, that will, our model will choose that particular hyperplane which completely separates our data, right? So C infinite means hard margin, that means option A, right? Now coming to next question, what do you mean by hard margin? The SVM allow very low error in classification. The SVM allow high amount of error in classification. Option C, none of this. Till now I have discussed this concept only. So option is no doubt A, right? SVM allows very low misclassification error, right? There is a very low error in classification, or very low error rate, right? That is what is the target of hard margin. Cool. Coming to the next question, the effectiveness of SVM depends upon option A, selection of kernel, option B, kernel parameters, option C, soft margin parameter, C, option D, all of the above. So correct answer is option, yes, D, right? Because see, I have told you C parameter is regularization factor. So if you can control overfitting using C, kernel parameter, gamma parameter, right? Very, very important. Overfitting, underfitting, it controls also, right? Selection of kernel, whether you should use linear kernel, whether you should use Gaussian or RBF kernel, whether you should use polynomial kernel. If polynomial kernel, what is the order? All these things you have to choose wisely. And if you choose all these things accurately, then only your SVM model is going to be very much effective, right? So option is option D. Correct option is option D. Okay. Coming to the next question. SVM are less effective when option A, the data is linearly separable. Option B, the data is clean and ready to use. Option C, the data is noisy and contains overlapping points. So what is the correct answer? Yes, obviously the correct answer is option C. SVM will not work properly if the data is noisy and the class are basically overlapped. Okay, because if the class are overlapped, it might happen that you might not find any higher dimensional space where they are linearly separable, and as a result you will be getting problem in the hyperplane, right? So the option is option C. If the data is noisy, overlapping data points are present, that time it will not work, right? So like here you can consider this particular scenario and you can clearly understand that here two different class, one class data point belonging to this black color, another class data point are denoted by this red color. They are completely overlapped. Now it is very difficult for SVM to find such hyperplane which basically separates two different class, right? So if the data is noisy or overlapping classes are present, then SVM will not work properly, right? That time you should go with some other algorithm, okay, for classification or regression. Okay, right? So this is what I wanted to discuss, some very important questions, right? I hope you have understood each and every concept. Keep these concepts in mind before going to any interview process, and I will be discussing some more in my upcoming videos. Thank you for watching.